Hello students, welcome back to the ninth video of this playlist. In this video, we will be solving question number 9 from the recent past paper of Pure Mathematics 1, which is the May 2023 P1 paper. So let's get started with question number 9. At first, part 1. Part 1, here you can see a figure 3. It shows a trigonometric curve. So figure 3 shows a part of the trigonometric function with equation y equals to f of x. So part A of 1, it's asking to write down an expression for f of x. Okay. So we can see the graph of f of x in figure 3, it's given. So now we need to write the expression for f of x. So what's the expression for f of x? So try to relate the given curve with trigonometric graphs like sine, cos. Tan is definitely not, because tan theta has what? Asymptotes. There's no asymptote, so tan theta, it's not tan theta. Either sine theta or cos theta. Now sine 0 degree is what? 0 radian, it's 0. But here we can see it is intersecting at 3. So definitely it's a transformed graph. So we know that cos 0 radian, it's what? 1. So 1 times 3, if you multiply 1 with 3, you will get what? The y coordinate 3. So this is basically the the sketch uh, the graph of cos theta definitely, but it is transformed. It is vertically stretched by scale factor 3. So for part A, this is the graph of y equals to 3 cos x or theta, f of x, so 3 cos x. That's it. Okay, next is part B of 1. Here the question is asking, on a separate diagram, sketch for x greater than negative 2 pi less than 2 pi the graph of the curve with equation y equals to f of x plus pi over 4. Show clearly the coordinates of all the points where the curve intersects the coordinate axis. Okay, so we need to sketch a transformed graph of the curve y equals to f of x. Okay, how's the how is it transformed? X plus pi over 4. So pi over 4 has been added within the bracket. So that means it is horizontal translation definitely, because plus it has been added. A constant has been added. So it is horizontal translation. And we know that for horizontal translation, always the opposite thing happens, right? So opposite things, it means what? You have they have added pi over 4 within the bracket. So what we will do, we will move the curve f of x to the left by pi over 4 units, by pi over 4 radian. Okay, so that means this curve will be moved to the left by pi over 4 units. Okay, so let's consider the axis. Okay, they have given some what blank space to do the sketch. So let's do this here. We don't need dotted line, we need solid line. Okay, okay, this is the x-axis and the y-axis. Okay, so now consider it should be from negative 2 pi to positive 2 pi. It should be accurate. Okay, so let's say this is pi over 2, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Okay, then this is negative pi over 2, this is negative pi, this is negative 3 pi over 2, and this is negative 2 pi. Okay, and the maximum value should be what? 3 cos theta. Okay, so this is 3, let's say this is 3, and this is negative 3. Okay, now 3 cos theta, 3 cos x plus pi over 4. Okay, so cos 0 degree is what? 3. It's basically 1, but 1 times 3, it is what? 3. So cos 0 degree is 3. So earlier in the graph, in the given graph, cos 0 degree was 0 radian, it was 3. But now it will move to the left by pi over 4 units. So it will be now here. Next, cos pi over 2 radian. Pi over 2 radian, it's what? It's 0. So 0, it will be moved to the left by pi over 4 units. So it will be here. Okay. Next, cos 180 degree, that is cos pi radian, it is what? Negative 1. So negative 1, it will move to the left by pi over 4 units. And then same goes for here. And then cos 360 degree, that is cos 2 pi radian, it is what? 3 again. Yeah. So it will be now moved to the left by pi over 4 radian. So it will be here. And then what? We have moved the graph to the left by pi over 4 units. So the, by pi over 4 radian. So that means cos pi over 4 is square root of 2 over 2. So square root of 2 over 2 times 3. So this y value at here, it will be the value for cos pi over 4. It will be here, the ending point. Okay. So let's connect them. Okay. And then it will go like this. Okay. This is the for the positive x-axis. Okay. Now go for the negative x-axis. Same thing. The all the x coordinates of the f of x will move to the left by pi over 4 units. Pi over 4 radian. So it will be here. And then it will be there. And then it will be there. And then it will intersect. It will end at negative 2 pi over 4 at negative 2 pi at exactly same y coordinate as this y value, which is 3 times square root of 2 over 2. So it will end here. Okay. Now add them up. Okay, it will keep going like this. Okay, this is the sketch. So now uh, they have asked, they have said what? To mention the where the curve is intersecting the coordinate axis, right? So this is pi over 4 radian 0. This is pi over 2 radian. This is pi radian. This is 3 pi over 2 radian, and this is 2 pi radian. So it is intersecting the x-axis again at this is pi 3 pi over 2. So 235. 235 is basically 5 times 5 pi over 4. Yeah. So 5 pi over 4 radian 0. We need to mention where it is intersecting the x-axis and the y-axis. So here it's what? 0 radian, and its y coordinate it's 3 square root of 2 over 2. Remember, this y-intercept and the endpoint and the two endpoints will be at the same level because they have the same y coordinate, 3 square root of 2 over 2. Then this point is negative pi over 2 this is negative pi, this is negative 3 pi over 2, and this is negative 2 pi. Okay, all are radians. Okay, so this x coordinate at the point of where the curve intersects the negative x-axis, it is negative 3 pi over 4 radian, y coordinate 0. Okay, and here it is intersecting the x-axis at negative 315. 315, it's basically okay, 7, negative 7 pi over 4 radian and 0, y coordinate 0. That's it. This is the sketch for y equals to f of x plus pi over 4 radian. That's it. Y value is 3, minimum y value is negative 3. That's it. So this is the sketch, and that's what part B of 1 has asked for. Fine. Okay, next is part 2. In part 2, it says we can see a figure 4. Figure 4, it shows another trigonometric curve. Figure 4 shows part of the graph of the trigonometric function with equation y equals to g of x. So part A here, it's asking to write down an expression for g of x. For g of x, we can see easily here. It is what? It is intersecting the origin, right? So we know that the graph of sine theta starts from the origin. So sine 0 degree is what? 0. Okay. But the difference is that it is definitely a transformed graph, we can see, because the period of sine theta it is 2 pi radian. But here we can see that the period has been halved. In pi radian, we can see a complete cycle. So that means since the period has been halved, so it means that the x coordinate has been halved. So x coordinate will get halved if and only if the trigonometric curve is horizontally stretched. So for horizontal stretch, we know that opposite thing happens. So since the x coordinates are getting multiplied by half, so we need to multiply 2 within the bracket of what? Of the function. So since we could figure out that this is the curve for sine theta, sine x, so the equation for this curve would be this is part 2a. This is y equals to sine what? Twice of x, because the x coordinates are multiplied by half, so that the period gets half. It is 1a. Okay, so we got the expression for g of x, which is y equals to sine twice of x. Fine. Okay, next is B of part 2. On a separate diagram, sketch for x greater than negative 2 pi less than 2 pi the graph of the curve with equation y equals to g of x minus 2. So clearly the coordinates of the y intercept. Okay, so here they are saying to sketch the curve with equation g of x minus 2. So this is what? Vertical translation. So the curve of g of x, it will be moved along the vertical axis, that is the y axis, by 2 units downward. Okay, so we have to go to the blank space again. Here we will do the sketch. Okay, for part B, g of x minus 2. So g of x minus 2. Okay, so let's consider the x coordinates. X, the leveling along the x-axis. So this is pi over 2, pi, 3 pi over 2, 2 pi. This is negative pi over 2, negative pi, negative 3 pi over 2 negative 2 pi. Fine. And we know that the maximum value of sine theta is what? 1. So 1 minus 2, it will be negative 1 now. So this is negative 1. This is negative 2. This is negative 3. And minimum value should be negative 3. Now consider uh, an imaginary axis. Let's say, since the curve of sine theta, it will be translated along the y-axis by 2 units downward. So now let's say this is the imaginary x-axis here. Now we will just draw the curve. Sine 0 degree is what? 0. So it will start from here. Sine 90 degrees 1. So it will be at maximum, and then again 0, and then minimum, it goes here, and then again, oh sorry, it is transformed, right? So I have considered the graph of sine x. It should be sine 2x, so it will be half here, and then at pi over 2 radian another one, and then minimum point will be at 135 degree, which is 3 pi over 4 radian, and then at pi radian there will be a complete period, so it will be like this. That's it. And then same another period from pi to 2 pi radian. Simple. It's simple but definitely time consuming, so you should be fast while you sketch it in the exam. That's it. So this is pi over 2 radian, this is pi radian, this is 3 pi over 2 radian, this is 2 pi radian. Okay, same goes for the negative x-axis, so it will be negative 1, then 0. A complete period should be between 0 to negative pi radian, like that. Like this. And then another complete period from negative pi to negative 2 pi. That's how, exactly. So negative pi over 2 radian, this is negative pi radian, this is negative 3 pi over 2 radian, this is negative 2 pi radian. And the minimum value is negative 3, this is negative 2, and then this is what? Negative 1. That's it. So it is intersecting the y-axis. The question clearly mentions that you have to mention the y-intercept. So this is 0 radian, y coordinate is negative 2. That's it. Done. So that's the equation. That's the sketch of y equals to g of x minus 2. That's it. So this is the sketch for y equals to g of x minus 2, and that's the end of question number 9. Fine.